Okay, so the first biogeochemical cycle that we're going to talk about is that of water, and I'm going to talk about this slide here in just a second. Water is super important to life. Most of your cells are made up of water. More than half of your body, in fact, is made up of water. For life as we know it, water is absolutely necessary. And water also has to do with the cycling of other elements as well. It has to do with the leaching of nutrients into the soil. So water, super, super, super important. I also wanted to point out here that only a very, very, very tiny fraction of the water available on this planet is fresh water. So you see here, salt water makes up 97.5% of the water on Earth. So it's a vast majority of the water here is salt. The fresh water, which is only 2.5%, is mostly inaccessible to humans. Okay, so most of the water is in glaciers, it's in snow cover, or it is underground. It's in areas that we can't actually access it. So only a very, very tiny fraction of the water on Earth is fresh, and only a tiny, tiny fraction of the fresh water on Earth is actually accessible to us. So we can only get to a very, very small portion of the actual water that's available. And this kind of goes back to that resource management thing that I had talked about earlier and limits to human population growth. There are already conflicts on Earth because of water. And as we have more and more people and increasing environmental disturbances and increasing global climate change, this problem is going to get worse before it gets better. Now that said, human beings have technology. We've figured out how to get the water that we need by doing things like digging wells, by doing things like having canals that allow us to transport water from one area to another. We can store our water. And so technology has helped us with this problem, and I think further technological developments will help us even more. Like there's some really exciting stuff with desalination right now, which is the process of removing salt from ocean water. That's for a later lecture, though. Anyway, I've talked about this enough. There's a very small percentage of fresh water that's actually accessible to humans. The water cycle has different ways of moving water, and this is them here. So if you imagine all the water that is on the surface, it can evaporate or it can sublimate. So if a droplet of water, if a molecule of water in the ocean goes from its liquid form and turns into a gaseous form, that is evaporation. You also have this notion of sublimation, which is where ice turns directly from a solid into a gas. And that happens in certain conditions, usually particularly dry, low pressure. But that is evaporation and sublimation going from the Earth directly up into the atmosphere. We also have condensation and precipitation. So condensation is what happens when it's cold outside and it's warm inside, or if you take like a cold glass, the small amount of liquid that forms on the edge of that glass is condensation. Precipitation is what happens when, so you have a cloud, and up in those clouds is basically just a whole bunch of water vapor that is all collected together up there. And what's going to happen is those water molecules are going to get too heavy, basically. And very often they're going to run into like a piece of dust that just happens to be in the atmosphere, and they're going to precipitate around it. So it's going to go from vapor form back into liquid form. It's kind of, with condensation, it's going from vapor form back into a liquid form. In the example I gave, it's on the edge of a piece of glass. For precipitation, it's going from vapor form, going from water vapor into a droplet of water, which obviously rains on it. So when water precipitates, it rains or snows back onto the Earth's surface. And most of the water that hits the Earth's surface actually is it's going to either evaporate again, or it's going to flow over the surface, or it's going to go into the groundwater. So you often see surface runoff, and surface runoff is the flow of fresh water over the surface. Obviously, maybe. And runoff can make its way into streams, as is the case with stream flow, and it can make its way into lakes, which will ultimately flow into the oceans, or it can run directly into the oceans themselves. Some of that water is going to get absorbed into the roots of plants, and the plants are going to actually exhale it in what is called evapotranspiration or just transpiration. And so some of that water is going to be in plants. Some of that water is going to exist in streams and lakes. Some of that water is going to run off over the surface. And some of that water is going to get into the ground. It's going to get into the groundwater. So if it's not taken up by a plant, if it doesn't evaporate, if it doesn't wind up getting pooled in a reservoir, it's going to do what's called percolating into the soil and into the bedrock, and it's going to become groundwater. So groundwater is a huge, reservoir of the fresh water that actually exists on Earth, and it's down there between boulders, between sand, between gravel, and eventually this is usually going to find its way to a stream or a lake where it's going to become groundwater again, it's going to go from groundwater back to surface water. And so stream flow doesn't happen because it doesn't happen because rain is coming directly into it. It's happening because there is water flowing from the groundwater below. So with stream flow, it's because water is coming up from the groundwater below. Runoff is because snow is melting or because it's directly raining onto the earth. So usually we use that groundwater as our drinking water a lot of the time. I grew up on a well, and so we actually, we had a straw that went down into the earth, and we sucked up water from the aquifer that was nearby our house. And like I said before, the water cycle has a lot to do with the other cycles as well. So your book says rain and surface runoff are major ways in which minerals, including carbon, nitrogen, phosphorus, and sulfur, are cycled from land to water. The environmental effects of runoff will be discussed later as these cycles are described. So when we get to those different cycles, we'll talk about the impacts of the water cycle on them. Let's see, I think I have a picture. So this is the picture from the book. I went ahead and found a picture I think is a little bit easier to look at from NOAA. Let's see, yeah. There we go. All right, so here is the water cycle. And again, the water cycle is driven by the sun's energy. The sun hits the ocean. It hits this liquid water, leading to evaporation, which is, again, the process of going from a liquid state to a gas state. Or it hits the ice and it goes from a solid state to a gas state through the process of sublimation. All right, it forms these clouds. Okay, these clouds will ultimately condense, okay, like water hitting the edge of a glass. This water is going to hit some dust particle or some ice particle that's already there, and it's going to precipitate and rain back onto the earth, or perhaps directly back into the ocean. After this, you have runoff, okay, which could be snowmelt runoff. It can just be rain runoff. That's just water hitting the earth and flowing down. And this surface flow can go into lakes. It can go directly back into the ocean. Ultimately, that water is either going to evaporate again, flow off, or it's going to percolate, and it says infiltration here. It's going to get its way back into the groundwater. Yeah, I would worry about the term percolation. Don't worry about the term infiltration right now. It's going to percolate back into the groundwater. Some of this is going to be absorbed by plants that are going to use it for their metabolic processes. They're going to use it to make sugars and stuff. They're going to use it to grow. And some of that water is going to be transpired, or it's going to undergo evapotranspiration or transpiration, and it's going to go from the plant back into the atmosphere. Okay, so I think that's all about the water cycle for now. Like I said, this is going to come back, and we're going to talk about it again when we talk about the other cycles, because the water cycle is important for those as well. Okay, cool. I'll see you in the next lecture, which is about the carbon cycle.